Hello everyone. We are back with the subject machine learning. The module is data preprocessing, and the topic of this video lecture is data reduction. This is the part 1. So basically, what is data reduction? It is a process that reduces the volume of original data and represents it in a much smaller volume. Data reduction techniques are used to obtain a reduced representation of the dataset that is much smaller in volume by maintaining the integrity of the original data. Means when we have a very large volume of data and want to use it for algorithm and ultimately the data is of very large volume. So there can be a way that we can reduce that volume without losing the knowledge or without losing its actual meaning. So data reduction is that process which actually reduces the data without actually not breaking its original meaning or original value. So data reduction keeps the integrity of the original data, though it is reducing it. So data reduction is the capacity optimization technique in which data is reduced to its simplest possible form to free up capacity on a storage device. There are many ways to reduce data, but the idea is very simple. Squeeze as much data into physical storage as possible to maximize capacity. I repeat this. Data reduction is a capacity optimization technique in which data is reduced to its simplest possible form to free up capacity on storage device. There are many ways to reduce data, but the idea is very simple. Squeeze as much data into physical storage as possible to maximize the capacity. Coming towards the benefits of data reduction, the first and foremost benefit we'll study over here. The main benefit of data reduction is pretty straightforward. The more data you can fit into a terabyte of disk space, the less capacity you'll need to purchase. So the data reduction can save energy, it can reduce your physical storage cost, decrease your data center footprint. Data reduction greatly increases the efficiency of a storage system and directly impacts your total spend on capacity. So let us discuss this in a little detail. When we talk about save energy, so how are you going to save that energy? Because they save energy of processing as well as your own energy. Reduce your physical storage cost because when you, as it is already mentioned about that more data you can fit into a terabyte of disk space, the less capacity you will need to buy it or purchase it. So it will reduce your physical storage cost. Increase your data center footprint means you do not have to be very bothered about data center. That will reduce its footprint. Data reduction greatly increases the efficiency of a storage system and directly impacts your total spend on capacity. That will reduce the total capacity and also it will increase the efficiency of storage system. And that will be affecting your total spend and capacity as well. So here are some of the techniques of data reduction. It that we will be studying one by one in a detailed manner. The first one is dimensionality reduction, numerosity reduction, data cube aggregation, data compression, discretization operation. So starting with the discretization operation, data discretization refers to a method of converting a huge number of data values into smaller ones so that the evaluation and management of data becomes easy. This discretization we have also discussed previously while we were dealing with transformation. So it is similar thing, discretization refers to method of converting a huge number of data values into smaller ones so that the evaluation and management of data becomes easy. In other words, data discretization is a method of converting attributes, values of continuous data into a finite set of intervals with minimum data costs. Means we can say that this is also a method of converting attribute values of continuous data into a finite set of intervals with a minimum data loss. There are two forms of data discretization. First is supervised discretization, and the second is unsupervised discretization. The supervised discretization refers to a method in which the class data is used, like we have the numbers from 1 to 10, and there is class number greater than 5, number less than 5. So ultimately, we will be putting the numbers 1, 2, 3, 4, 5 in the numbers less than equal to 5 and 6, 7, 8, 9, 10 into the number greater than 5. So this is like supervised discretization because already there was the class data. When talking about unsupervised discretization refers to a method depending upon the way which operation proceeds. It means it works on the top-down splitting strategy and bottom-up merging strategy. This will discuss it here. This is one of the example of discretization. We can understand this concept with the help of example. Suppose we have an attribute of age with the given values 1, 5, 9, 4, 7, 11, 14, 17, 13, 18, 19, 31, 33, 36, 42, 44, 46, 70, 74, 78, and 77. So this is before discretization. And if we go for discretization, the attributes after discretization is like the age 1549 is of child age. Then for the young, it will be 11, 14, 17, 13, 18, 19. Again, the mature age is 31, 33, 36, 42, 44, 46. And for old, 70, 74, 77, 78. So we can say that for the given number, we have discretized those numbers or those ages with the categories, right? So this we can say this is a supervised discretization. Now here are the techniques of discretization. The first is histogram analysis. Histogram refers to a plot used to represent the underlying frequency distribution of a continuous data set. Histogram assesses the data inspection for data distribution, for example, outliers, skewness representation, normal distribution representation, etc. Binning. Another is binning. We have already done this with the data smoothing. So it refers to the data smoothing technique that helps to group a huge number of continuous values into smaller values. For data discretization and the development of idea hierarchy, this technique can be used. Next is cluster analysis. Cluster analysis is a form of data discretization. Cluster algorithm is executed by dividing the values of X numbers into clusters to isolate a computation feature of X. Data discretization using decision tree analysis. Data discretization refers to decision tree analysis in which a top-down slicing technique is used. It is done through a supervised procedure in a numeric attribute discretization. First, you need to select the attribute that has the least entropy, and then you need to run it with the help of a recursive process. The recursive process divides it into various discretized disjoint intervals from top to bottom using the same splitting criteria. Data discretization using correlation analysis. Discretizing data by linear regression technique, you get the best neighboring interval and then the large intervals are combined to develop a larger overlap to form the final 20 overlapping intervals. It is a supervised procedure. So I'll take you back to the techniques. Histogram analysis. Here with the term histogram, you all must have drawn the histograms in your graphs. So with the help of that histograms, we can inspect the outliers, normal distributions, and the skewness of the data. Binning, we have already studied how we are discretizing using binning. The cluster is what we are making the cluster of similar values. If there is some different value, like we are making the clusters of 1 to 20 value. If there is number 50, you can ultimately find that 50 is some sort of error or a kind of outlier. So with the help of cluster analysis, one can do the reductions. Then data discretization using decision tree analysis. Again here, we are discretizing the data with the help of decision tree analysis, in which a top-down slicing technique is used. Here, this method is a supervised procedure, and here we just select the first attribute, which is having the least entropy. And then we continuously select the recursive process. The recursive process divides it into various discretized disjoint intervals from top to bottom using the same splitting criteria. And the last is discretization using correlation. Correlation means we are finding the relation between two attributes. So if we're talking about correlation, then ultimately we are talking about linear regression technique. Here you can, one can get the best neighboring interval. Then the large intervals are combined to develop a larger overlap to form the final 20 overlapping intervals. So this is also a supervised procedure. Now coming towards why this discretization is important. Have you thought that? As we know, with infinite of degrees of freedom, mathematical problem passes with the continuous data. So for many purposes, data scientists need to implement this discretization. It is also used to improve signal noise ratio. Many times it happens that the data are in continuous values and in a continuous signal flow. So in that case, discretization is required, and ultimately this discretization is used. So this is how we have studied about data reduction. We have gone through the introductory part. We have found its benefits. Gone through the techniques that discuss the technique one, discretization operation. What is that? And we have also studied the techniques how we are achieving this discretization, which involves histogram analysis, binning, cluster analysis, discretization using decision tree, and the last is using correlation analysis. And last we have discussed why is this discretization important for us. Thank you for watching this, and we'll be continuing the data reduction in coming video lecture. Thank you.